Recording progress.
So, hello everyone. Okay, let me share the screen again. So, this is the first problem of today's educational round. And in this, we are given that Monocarp visited a retro arcade club with arcade cabinets and they got furious about the catch the coin cabinet. Now the games of this are pretty simple. X axis is directed as left to right. Y is directed as from bottom to top. And the center of the screen has coordinate 0, 0. So at the beginning of the game, the character that is Monocarp is at the center, that is 0, 0. And we have to find, like, there are n coins, so we just have to tell that whether how many of these n coins can Monocarp collect. So there is one thing that after each second, the coins will fell down by one, like they'll go fell down to the cell which is right below it. So we have to, like, there are eight steps, like basically in Monocarp can move in 8 directions that are these. If Monocarp is at XY, then they can go to either, like, to the right, to the left, to the top, to the bottom, or in 4 directions diagonally. So how to solve this? Like, if we look at this, like, we just have to look at the distance between you or Monocarp and the coins that is being reduced after each move. So let me explain this in writing pad. So let me know once the writing pad is visible. Okay, the writing pad is visible, right? Okay, so we are, let's say this is the 0, 0, and the coin can be anywhere. So after each second, the coin will go one step down, and the right or left doesn't matter, like how far it is. The thing is, in each step, you can go one down. And since you can, like, simultaneously go towards right and down, so like you can go any step towards right. But the thing is, if the coin is already below this point, this is 0th level, this is -1, this is -2. So if the coin is below this level, below -2 or at -2, no matter what where it is, you won't be able to catch it. Why? Because see, you move one step towards, closer towards it, and it falls below down. Otherwise, wherever it is, you'll always be able to catch it because you will be always like moving in towards its direction and you will be going downward simultaneously. And since this can go up till infinite, like you don't have a definite time before which you have to catch it. So you can just keep on going one step closer to it in its direction and going downwards. Is it clear?
No, sir, I'm not able to get the observation that you said.
Like which observation?
No, just now you said that we can catch it, right? That observation I wasn't able.
Your voice is breaking. Yeah, like I'm not able to understand. What did I say? Hello. You can write down in the chat. Like in the chat also you are saying that I said, like what did I say? Like, what part did I say that you are not able to understand? Yes, you can catch. Like you can move because like you don't have to catch it before like why you won't be able to catch it even if it's this much far, it will keep on going down and you can just one step closer and towards right, one step closer and right, one step closer and right, one step closer and right. Finally, somewhere along the line, these two will collide, right? But if it's already below down here, then no matter what you do, this coin will always be below you only because you can just go one step down every second and the coin is also going down. Okay, so let's go. I'll look at the implementation. So the implementation is simply this, that if for a coin, the y coordinate is less than -1, that is, it is -2, -3, or anything below it, you cannot catch it. So your answer is no. Otherwise, your answer is yes. Any doubts in this? So let's go to the next problem.
Sir, you were saying.
Like again, like I'm not able to understand. Like, is it only breaking for me? Like, was anyone able to understand what was the doubt? Like, you can maybe unmute yourself and tell me. Okay, nobody was able to understand. So I'm going to proceed right now and we'll discuss if you have we can take it out at the last. So this is the second problem, and in this problem we are given that we are given two strings A and B, both consisting of lowercase Latin letters. A subsequence of a string is a string which can be obtained from by removing several letters, possibly 0 characters from the original string, and a substring of a string is a continuous sequence of that string. Now, for example, if we consider ABC, then all of these are its subsequences and all of these are its substrings. So our task is to calculate the minimum possible length of the string that contains A as its substring and B as its subsequence. All right. Now, the first line contains the number of test cases, and this is the important that the length of string A and B both are between 1 and 100. So what does this tell anyone? Like if test cases are between 1 and 10 to the power 3, that is 1,000, and length of A and B is between 100. 1 and 100. It simply tells us that we can solve this in time complexity of length of A times length of B, that is in quadratic, not linear, but quadratic complexity, time complexity. So now what we have to do, we have to find a string for which, like the string, minimum possible length of the string, we don't have to find the actual string, but we need to find the length of the minimum possible length of the string that contains A as substring and B as subsequence. So A as substring and B as subsequence. Let's look at this here. So A as substring. And B as subsequence. Now, like, if we have to do this in, like, A is fixed, right? A will appear somewhere in between, right? Yes, no? What about B? What about B? B will appear, but it won't appear as contagious, right? So what do you think? Like what should be the string over which we should iterate? We should iterate over, okay, B. Okay, somebody said A. Like you can do it both ways, but one way is simpler. So how can we do this over B? Iterating over B, like what? Why should we iterate over B? All as will be in B. Like I'm not able to understand. All as will be in B. Like everything in A will also be in the final string. Yes, perfectly. At every index, like can you explain this a little bit? Yes. So what we'll do, just give me a second. We'll go through, we'll iterate over B. We'll iterate over this string. B is a subsequence. So this is my string B, and from this, I'll just calculate like how many of these can be part of A. Like, and whatever can be part of A, like let's say 3 can be included, 4 can be included. And the thing is, if I'm including something, like if let's say I'm saying that okay, this string matches some, like I'm saying like I'll fit A in between. Let's say this is A, B, C, D, E, F. So from this string I'll start. Okay, I'll check whether this is the point, right? So in my string A, whatever my string A is, I'll check that from this I'll start iterating over this. Like for every string, for every position I'll iterate through J in my string A. This is my string A, this is my string B. So what I'll do, I'll check whether this character is equal to this character. It's not. So till I'm trying to fit as many characters as possible. So let's say this character fits, this character fits, and this character fits. Basically, these characters are fitting here, here, and here. So this means, what does this mean? Like, first of all, like not like this. Like I'll always try to fit, like I'll check whether after how much point this C is matching here. So let's say my C matched here. Then I'll check not E because there's a D in between. So I'll check where up till where I'm able to match. Like if let's say my D comes after this point, my D comes here. So how, like where will these characters go? This is, let's say, X, Y, Z. Where will these go? These will go between C and D. These will go in here. Like I'll explain this again. Like you don't have to perform least LCS if you like iterate over B. So how? See, let's say these are the characters in B. So what I'll do, using for every index, I'll start from there. Like let's say from here onwards, I'm saying that my string A appears. From here onwards, my string A will start to appear. So it will always be contiguous, right? So if it is contiguous, this is my A1. Now next I'll check whether this can be my A2. If this can be my A2, well enough. Otherwise, A2 will be in between. Then I'll check whether this character can be my A3. Again, it cannot be A3. So A3 will be in between. Then I'll check whether this can be my A4. If it can be A4, that is my this character, this whatever this B1, B2, B3, B4. If B4 is equals to A4, then okay, this is okay. Then I'll check whether this can be my A5. So let's say it can be good enough, move ahead. So then I'll check whether this can be my A6. No, it cannot be. So I'll say A6 is there. Then I'll check A7. A7, it cannot be here. Then I'll check A8. So A8, it can be. So how many characters are coming in between? These two and these two. So my answer, like this way, if I start from this point, what is the length of my string? The length of my string is the length of string B plus the characters that I have inserted. So these are 4. So this way I'll do for every index. Is it clear? Is it clear now? So this way I'm not actually doing any LCS. I'm not finding the LCS. If you iterate over A, it will be a little bit more like complex, but this way it's easier. Is it clear? Yes, no? Otherwise I'll explain again. Let's take an example. So let's take A is, let's say my A is CDE and my B is ABCE. A, B, C, E, F, G. So let's say I'm iterating through this. So currently this can be my C. Can it be my C? No. So C will come before it. Can it be my D? No. So D will be my before it. Can it be E? No. E will come before it. So rest of the things will be same. A, B, C, E, F, G. What is the length? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this way I got 9. So then let's try to make it this as my starting point. So can this be my C? No. Can this be my D? No. Can this be my E? No. So this way also again 9. This thing, can it be my C? Yes. So C will come here. Can this be my D? No. So D will come between. Can this be my E? Yes, it can be your E. So this way, only one character came in between, so the length is 7. After this, everything will be 9 only. This cannot be your C. The following cannot, like, okay, this cannot be your C. So C will come before. This cannot be your D, so D before. But this can be your E. So this way, the length will be 8. 6 plus 2 characters in between. For this, it will be 9. For this, it will be 9. So 9, 9. So what is the minimum of these? 7. That is your answer. Is it clear now? You don't have to argue in the chat, okay? Like, don't, like, try to have as minimal conversation among yourselves, like, try to keep the conversation as minimum as possible. So is this thing clear? Okay. So let's look at the implementation. So this is the implementation. First, take the two strings in input, find their length. Answer can always be n plus m. Just concatenate the two strings. Then, if I'm iterating over the second string, the m was the length of the second string, then I'm starting from this point. I'm just checking this thing only. Like if my current index can be equals to this, go to the next index. Otherwise, it will always be coming in between. Finally, all the indices that I'm able to pass you like this will be subtracted from the total number of characters in B. Why? Because those are matching in A also. So this way, I'm trying to find the minimum answer. Is it clear? The minimum value. If I start from every index of B. If I start my matching for every index of B. Is it clear? What about others? Okay, so let's move to the next problem. So in this, we are given that a movie company has released 2 movies. These 2 movies were watched by n people. For each person, we know whether their attitude towards the first movie, like what was their attitude for the first movie, like what's that, neutral, liked, or disliked. And we also know what their attitude was towards second movie. Now, if a person is asked to leave a review for the movie, then if that person liked the movie, then they will give it a positive review. If they disliked it, they'll give it a negative review. Otherwise, they'll give it a neutral review. If they give it a positive review, then the movie's rating will increase by this, at least by 1. And if it, not at least, it will increase exactly by 1. And if it's a negative review, then it will decrease exactly. It will decrease exactly by 1, and otherwise it will not change. Now, every person will review exactly one movie. And for every person, you can choose which movie they will review. So the company's rating is the minimum of the ratings of the two movies. So our task is to calculate the minimum possible rating of the company. Like what is the what is the maximum possible rating? If we can decide which person will review which movie. And how is the company's rating decided? It is decided by the minimum rating of the two movies. So let me explain this problem here. So see, there are two movies. Each movie, if receives a positive review, their rating will increase by one, otherwise their rating will decrease by one. So for two movies, you know, for n people, you know already whether they like or dislike. Like for there are n person, they you know for each person whether they like, dislike, like, dislike for both the movies. Now, for each of these persons, will decide whether this person will review first movie, second movie, like which movie. And finally, you will get two ratings for the first movie and second movie. The minimum of these is the company's rating, and you have to maximize this. Now, what do you think? Is this a greedy problem? Or like what? It's a simple, very simple greedy problem. See, look at this. There are four cases. A person is giving positive rating to both. A person is giving negative rating to both. A person is giving positive to first, negative to second. A person is giving negative to first and positive to second. There isn't any other case, right? So for these two, no matter which movie will this person review, it is fixed that the rating is going to either increase or decrease, right? Yes, no. So like if it's both plus plus, then it means that if this person views a positive movie, any movie, either first or second, their rating will definitely increase. So let's say we know how many positives we have. Like positives means that we'll divide these positives among the two movies. And we have these negatives also. So we'll divide these also among the two movies. Okay. And since we have to maximize, we'll divide these equally. Now, these are the things. Like first movie's rating will increase. And according to this, second movie's rating will increase. Now we won't divide them equally. Why? Because we'll see how much positive we have for the first. Like, by the way, which movie should this person review and which movie should this person? This person will always review first movie. This person will always review second movie. Yes, no? Because what is the point of this person reviewing? Like it depends on us which movie will this person review. So why give this person this second movie? So what we'll do, this is the rating of initially. Let's look at all these persons, give them the first movie. This is your rating for first movie, RA. And this is the number of persons, like this is the rating for second movie, RB. Now we should give positive and negatives among these such that the rating of these movies can be brought, like let's say RA is 3, RB is 6. So we should divide positive and negatives. Like we should give these more positives and some negatives to these. This. Why? So that they can be brought as close as possible to each other. Because otherwise, we don't have to maximize the difference between these two. We have to minimize such that RA can be brought as more as possible. And once both RA and RB become equals to 6, let's say this happens, then we'll divide equal number of positives and equal number of negatives, because we have to maximize the minimum of both of these. Is it clear? What about others? So let's look at the implementation. So in this, I have first taken the A and the people's like the reviews for the whether they like, dislike, or be neutral for the first movie, and then for the second movie. Then SA is the rating. By the way, there is neutral also. It actually doesn't matter. Like if it's neutral, the only thing matters is this plus plus and minus minus. Otherwise, if it's plus 0 or plus plus 0 or plus this thing, then definitely this person should review the first movie. Otherwise, if it's 0 plus or minus plus, then this person should review the second movie. If it's 0 0, then it doesn't matter. And other than these, we have discussed the cases, right? So that's why I didn't take this neutral. Positives will be divided equally and negative, like not equally. After we have ratings equal, then positives and negatives will be divided equally. Otherwise, positives and negatives will be divided in such a way that we are trying to make the ratings equal. So this is for the first movie, this is for the second movie. SA is rating for the first, SB is rating for the second, positives and negatives. So if both are one, both like the reviewer will like both the movies, positive is increased by 1. If both are -1, negative is increased by 1. If AI is more than BI, this simply means that this person should review this first movie. Why? Like if it is 0 -1, then also it's beneficial. If it is 1 and -1, like this is 1, this is -1, then also it's beneficial. If it is 1 and 0, then also it's beneficial. It cannot be -1 and -1 or 0 0. Why? It can be 0 0, but it cannot be -1 -1 or 1 1, because we have handled those two cases here. So if this is the case, then it's always optimal to give this person the first movie. So if it is like, now there are two cases, AI can be 0 or AI can be 1. If AI is 1, increase the rating of first movie. Otherwise, simply give this person to review the second movie and accordingly increase the rating of second movie. Now, like I said, equally divide positive and negatives. How to divide positives? I have some positives. While the rating of SA is less than SB, keep giving SA, like keep increasing the first movie's rating with these positive reviews. Otherwise, increase second movie's rating. While negative is there, if SA is less than SB, then give it to SB, second movie. Decrease the rating of second movie. Otherwise, decrease the movie rating of first movie. Finally, you can print minimum of rating of first movie or rating of second movie. I hope this is clear. Like, is it clear or any doubts in the implementation? Yes, if you have a doubt, you can ask me. Like, just unmute yourself.
Hi,
Yes, hello.
so I wanted to ask, are we trying to make everything
Your voice is also not clear. Like, I'm not able to understand what you're trying to say.
okay, well, how about now?
Yes, now you're audible.
Okay, are we trying to make the rating of SA and SB as close as possible?
Yes, we're trying to bring these as close as possible. SA is the rating of the first movie and SB is the rating of the second movie.
Okay, I see. Thank you.
Like, why try to bring them as close as possible? Because, see, let's say rating of the first movie was 7 and rating of the second movie is let's say 19. Now I have some positives. Like, positives simply mean if I have 6 positives. So if I give this one these 6 positive reviews, its rating is going to increase by 6. Otherwise, if I give this all of these 6 reviews, positive 6 reviews to this, its rating is going to increase by 6. Similarly, I have some negative reviews, like which are going to be negative for both of these. So let's say these are 3. So if I give these 3 negative reviews, its rating is going to further decrease. Now, why to bring these as close as possible? There is no point in increasing this because my final rating for the company is going to be minimum of SA and SB. So there is no point in increasing just one of these. I have to increase both of these. So in order to increase both of these, they should be as close as possible. Why as close as possible? Simply because your minimum should be going as, like, the value which is lesser should be going as close as possible to the bigger value. And the bigger value shouldn't be much far away from this value. That's mean, because if this is very big than this, that means that you are giving this unnecessary positive reviews. You should be giving positive reviews to this, and the negative reviews should be given to the movie which has already much more higher count of rating. So that's why these should be as close as possible. I hope this is clear. So let's go to the next problem. So in the next problem, we are given that we are playing a famous computer game where we have various skills, and like where we have various skills we can level up. So today we focused on smithing skill, and our tactic is obvious: forging weapons from ingots and then melting them back to return the materials partially. For simplicity, every time we create an item, we get 1 experience point, and every time we melt an item, we also get 1 experience point. Now there are n classes of weapons we can forge and n times of metal ingots. So we can create 1 weapon of the ith class, spending AI ingots of the metal of the same type, and melting a weapon of the ith class that we had crafted earlier returns us BI ingots of the type of metal it was made of. So we spent it AI ingots and in return get BI ingots. So we have CJ metal ingots of the jth type, and we know that we can craft a weapon of any class from any metal type. So each combination of weapon class and a metal type can be used any number of times. So we can use any combination, and we can decide that what will be the weapon class from the n weapons. There are n weapon classes, right? And we can decide what will be the metal type. So there are m types of metal ingots, right? So we have to find what is the maximum total amount of experience we can earn. So let me explain this. So there are n classes, and there are now for each of these classes we are given that we have to, like, there are n classes. So for the ith class we're given we need to spend AI in metal ingots, and we'll return, like we'll earn or we'll get back BI. And we are given that initially C1, C2, all the way up till Cn is the number of metal ingots we have of ith type. And each time we are we are building one like weapon and we are melting it down, our experience points is increased by one each time we build it or we melt it. So, like, what do you think? Like, what is this problem? Is that observation, greedy? Like, what do you think? It's like it can be sorting. Like, if like it it is greedy, but like if you can think, like it can also be solved using dynamic programming. But your greedy solution will also work if you are able to find like what you're trying to maximize. First of all, if we are looking for how many times, like what is the maximum number of times we can build and melt it again. So first of all, forget about melting. If we are able to build, we'll always melt it down. Yes, like there is no point in just building one metal weapon and not melting it, because once you have built it, there goes nothing to melt it down. So you'll always melt it down and you'll always get some metal ingots in return. The problem is that there are n classes of weapons and m metal ingots. So for each class you're given how many metal ingots you require to build it and how many metal ingots you'll get in return once you melt it down. So initially you're given for each class how many metal ingots, like you're given how many metal ingots of ith type you have. There are m metal ingots, right? So there will be C1 to Cm, not Cn. And finally, you have to, like, your skill increases by one if you once you make a weapon or once you melt it down. So you have to find what is the maximum skill that you can get. So I was saying that if you are able to make one weapon, you'll always melt it down. There is no point in stopping at that point of like once you have built a weapon, because you get one extra point to just melt it down, and you don't require any metal ingot once you have builded one weapon. You just have to melt it, right? Yes, no. So So AI is the number of metal ingots required to build the ith class of weapon, and BI is the number of coins required to, like BI is the number of, not coins, metal ingots that will get in return. Let's say coins only instead of metal ingots. Let's say for the ith class, we require AI coins to make the weapon, and in return we get BI coins. And initially we have CI coins of ith type. Mm, If we use the ith type of, like, it's not, this is not class, but this is ith type of coin. If we are using this, we have to use AI types of coins. Let me, like, Okay, this is ith class, and this will require AI coins of type and BI coins of type. Why coins of type? Because there are M coins of type or M metal ingot types. And initially you're given the number of these. Like what is it? Like how many ith type of coins do you have? Is it making sense? What is the significance of type? Okay, it's still not clear. See, you can create one weapon of the ith class if you spend AI ingots or AI coins of metal of the same type. Like it has to be same type. So if you decide that third type of coin or third type of ingot you'll use, so you'll have to use AI number of those, and in return you'll get BI. Let's say BI is 2, so you'll get 2 ingots in return of the same metal type. So you decide that okay, which weapon you'll make and which coin type you'll use or which ingot you'll use. So you'll make the fifth weapon using the third type of ingot. So for third type of ingot, you'll have to use 3, like 3. Where is this 3 coming from? See, for every for every for every class, for every class, 2 numbers are decided, AI and BI. So let's say for the fifth class, AI is 6, BI is 4. So this means you'll use 6 coins and you'll use 6 ingots, and in return you'll get 4 when you melt it down. Now you have to decide which coin will you use, so or which ingot you'll use. Okay, so let's say you decide that you'll use the third ingot. So this is this and this you're deciding, that fifth class and third ingot. So basically this means you'll have to use 6 ingots of third type of ingot, and in return you'll get 4 number of third type ingots. Is it making sense now? And initially you're given C3 as the number of ingots that you have available initially. Is it making sense? And once you're able to build this and melt it down, you'll get 2 experience points, one for building it and one for melting it. Indirectly, you can say that if you're every time you're forging, you'll get like you're using 3, but the thing is, you won't be able to forge it unless you have at least 6 ingots of third type of metal. Why? Because you're not actually using 3, you are using 2. Like at the end, you have used only 2 because you got in return 4. You used 6, but you got return 4. But the thing is, you are not able to start the forging unless you have 6, right? So now, okay, I think the problem statement is clear. Now, what is critical? Like how many number of ingots are being used? Actually, how many ingots are being used? It is AI minus BI, right? Yes, no. For forging and after melting, how many ingots of ith type metal for the ith class is being used? So for every class, let's say I calculate this AI. What is AI minus BI? Like this, what the difference for this, and I map this with 2 things. I need 2 things. What are these 2 things? Either BI, like how many am I getting in return, and the second thing is the ith class. So if this many ingots are actually used, I'll get, for this I'm mapping this value with number of ingots actually used with number of ingots in return returned, or like that you have earned along with the class, ith class. So if I have this kind of thing, how can I use this? And tell me one more thing, BI should be more or less like the number of ingots that you're getting in return. If you have to forge as like if you want to forge like maximum number of weapons, you have to, if you are able to forge, if you're able to make more number of weapons, you'll be able to get more experience points for making them, more experience points for melting them. So BI should be more or less. For the same value, for the same number of ingots used, whether you should get more coins or more ingots back or less number of ingots, more or less, it should be more. Why? More ingots you get in return, more weapons you'll be able to make. So let's say you have this thing, you have already this thing, then what will you do? You'll iterate through this thing, like the differences, like what is the difference between AI BI. For that, you'll know how many actual number of, let's call this as like difference, what is the actual number of ingots being used, and you know that what is the ingots that you are getting in return and what is the ith class. So for this, from your array C, you'll find what is the first ingot which has at least these many, like let's say this is your C1, C2, C3, all the way up till Cm. So let's say that you have this in sorted order. So you'll find the first ingot which has at least this AI number of ingots. Why? Because like I said, you won't be able to start the initialize forging process unless you have these many ingots AI. So you'll find the lower bound of this AI. For current difference, you'll have BI I, and because of I, you'll get the AI also. So you'll get this AI, that is start from this point, start from this ingot, it start from this type of ingot. So from that, what you'll do, you'll just keep on forging. How? You'll count. What do you like? What will you count? What will you count? How many values are here? Like C3, like these can be same, right? This is also 5, this is also 5, this is also 5, this is 7, 7. So these three are 5. So there are 3 types of metal ingots that you can actually use at the start. So let's say you decided to use these 3, and what is the number of experience points that you'll get? 2 times 3. Why 2 times 3? One for building and one for melting, right? Yes, no? And multiply, what should this be multiplied with? The number of metal ingots that we have minus the number of metal ingots that we get in return, divided by the number of metal ingots that are actually being used. That is this difference. Let's call this as D. So like this 2 is for forging and melting. Once we have forged, we will always melt. This is for this count. How many number of like the how many number of ingot types we have which are same and more than first time more than or equals to AI. And this is the number of times I can like have this process for these. CI is the number of metal type ingots I have for this ith like metal type. BI is the number of metal ingots required, like metal ingots that I'll get in return. So divided by the number of, like this is actually the available number of metal ingots, because these are I have initially, and this is what I'll get in return. And this is being used every time. So divide by this. So I'll keep on doing this. Like I have done this for 5, then I'll do this for 7. How many times I have 7? While I cannot reach, while I can reach the end. So I'll explain this using like code, otherwise it won't make much sense. So what I have done, I have taken the N and M as input. I have taken the number of ingots required for ith class of weapon. And then using this map, like using this loop, I am first taking the number of ingots that I'll get in return for ith class, melting the ith class weapon, that is Bi, and then I'm finding this difference dot find. Like what is this difference dot find? This is basically, if this is a map, like this just tells me that whether this value is already there or not in the map. If it is, I'm checking whether difference of AI minus Bi, and this is first. So difference of AI minus Bi is storing this pair that I've already explained. This is the number of ingots that I will get in return, and this is the ith class. So if this value, that is the number of ingots that I get in return, is currently less than this Bi, it's more than Bi, then I'll update this. Otherwise, if this value is already not present, I'll go to the else section. Then I'm taking vector, like this C vector in input, and for taking this, I'm not just taking the values in input, I'm calculating their count. So that, like I said, when I'm iterating, I can just, using their count, I can multiply it here 2 times the count minus current, like not minus, multiplied by current, and current is nothing but this value, how many times I can perform the forging. So how to do, like what I'm doing with difference, I'm iterating over these values, like what is the actual number of ingots used versus the ingots that I get in return and ith class. So I'm finding what is the first ingot type which can be used, which is in C. And I'm finding the lower bound of A. This is just simply binary search, finding the first time when I can use the ith ingot type. Basically, it should be more than this thing, right? It should be more than AI. So once I find it, I'm iterating from that way onwards. So I'm finding the count. Count is nothing but this thing. The number of times this ingot type is there, like 555. It is 3 times, right? So count of it, and I'm finding the current, how many times I can forge with 1. So multiply it with 2 times count. Count is how many times I'm getting 555 or 777 multiplied by CI minus DI divided by difference. How many ingots are actually being used? This is difference. So then we can erase this value from C. Why erase it from C? Because this is already used. Like this type of ingot type is used in order to make this AI. Like I'm using this to make the ith class weapon. Also, once this is done, increase your C. Like this many counts, this is already used. And finally, like go forward. So this much, this is removed, these ingots are removed, these are used, and this is again finding the lower bound, that which else ingot, like which ingot can further be, which ingot type can further be used, because again you need at least AI number of ingots to start the forging. So you are checking in your array C. C has the total number of ingots, and there, like what is the count of ingots. So in that you are trying to see now which else ingot type is there which has at least AI count. So upon doing this, finally we can print answer. Is it clear? I think I have like complicated this part, but once you have this thing, you can simply just apply binary search or binary search or just simply lower bound and find, okay, if you want to forge this ith class weapon, then for that you will have to use which type of ingot, at least which type of ingot. So that's it. Okay, so if you don't have any question, then feel free to drop off, and thanks for joining. Bye bye.